Okay, so you have learned one thing now, which is called angle of friction. And that is the angle which the resultant of friction and normal reaction makes with the normal reaction. Okay, now there's another angle called defined as angle of repose. Now suppose this is a surface, and suppose it is hinged at this end and a block is kept, and from this end you are lifting this plank. Now at certain position, at certain inclination with horizontal, the block will start to slide on the plank. You're lifting it, actually you're rotating it about this point, and at certain point the block will start to slide on the plank. The angle which the plank will be making with the horizontal at that moment, that angle is called angle of repose. And using basic mechanics, you can find out what will be the angle of repose. When it just starts to slide, then let's see what will be the forces acting on the body, so that we can find this angle theta if we know the mu. Mu experimentally can be found out, so most of the time would be relying on the value of mu, because mu experimentally can be easily found out. So supposingly that we know mu and we are trying to find the angle of repose theoretically. So the forces acting on this block is mg downward. If it is about to slide, then it is about to slide downward. Then there's about to happen a relative motion in downward direction, down the plane. Now the friction force at that very moment when it just begins to slide will be just opposite to the force which is pulling it downward. That means if the block has a tendency to come downward, then the friction will try and avoid the relative motion that is impending. That means friction will act in upward direction. To find the direction of friction, you should always consider that suppose there is no friction, then in whichever direction the motion is happening, the friction will be acting opposite to that direction, because as we have discussed before, friction tries to oppose the relative motion. And if this block is coming down, the only way to oppose the relative motion for friction is to act on this block in upward direction, so that it try and balances the force which are acting in downward direction and try and cancel all the forces so that the block remains stationary. So if it is coming down, the friction force will be acting upward. That we understand. So the friction force would be acting upward. These are the two forces, and of course you have normal reaction. Now, if it is just about to slide, then the forces are exactly balanced, and any more inclination will result in downward motion of the block. So at this very moment, what you have here is friction must be balancing mg sine theta. This angle would be theta. Okay, this is mg sine theta will be acting down the plane. That should be balanced by friction, and mg cos theta should be equal to normal reaction. Old story. We are breaking the components of the vector along the plane and perpendicular to the plane. That means, and friction, as we know, is mu times n. N we know is mg cos theta. This is the value of friction, and this should be equal to mg sin theta. So from here we can see that tan theta turns out to be mu, and this theta also turns out to be tan inverse mu. That means the angle of repose is also turning out to be tan inverse mu, like we had angle of friction. So theta in this case also turns out to be tan inverse mu. That means the angle of repose is the same as angle of friction. Okay, that's it. Now what we are going to start, we can start a rigorous session of problem solving, because that's what is left in this chapter. So we're going to start problem one by one. We're going to complete all the kind of problem that could be asked from this particular section. Okay, so let's begin. We'll start with easy ones and gradually will increase the toughness level. This is a wedge fixed on the ground, and you have a block at the top of the wedge. Now the upper half of the wedge is frictionless, smooth, and the lower half has some friction. Now the question is, what should be the value of coefficient of friction of the lower half of the wedge, so that the block, if it starts from rest, when it comes down, the velocity becomes zero, that it comes down to a rest position. So if you are leaving this block, because the surface is smooth, obviously it's going to come down, it's going to pick some velocity. So at this point it will have some velocity, and after that the velocity should keep on decreasing, so that when it reaches the bottom, the velocity just becomes zero. Okay, and this angle theta is given, so you have to find your answer, value of mu in terms of theta. I'm giving you options. Suppose mu could come out as sine theta, it could come out as cot theta, it could come out as 2 cos theta, it could also come out as 2 tan theta. So out of these 4 possibilities, which one is correct?